All right, here we go, page 7. Lynn Pike, a pharmacist, needs 70 liters of 50% alcohol solution. So it's mixed with water, assumingly. She has available to her 30% alcohol, assume an unlimited amount, and she also has 80%. So she's going to combine these two to somehow come up with a solution that is 50% alcohol. In other words, if she put like all the 30% into it, she'd have 30% alcohol. If she put all the 80% in, she'd have 80%. So if she does the right combination, she'll get just 70% or 50% alcohol out of her 70 liters. How many liters of each solution does she need to mix to get the 70 liters? So we're going to do this with two variables here, because how many liters of each solution? Let's let X equal amount of 30% solution that we're going to use. We'll let Y equal the amount of 80% solution that we'll use. And we can already write our first equation, because I'm going to take the amount of 30% that I use plus the amount of the 80% that I use, and they better add up to a total of 70 liters, because she wants to have 70 liters of this stuff when she gets done. So there's our first equation. Let's put a little pin in that. See if we can write a second equation. Now these used to always drive me nuts to try and explain them, but here's what's going on. How much alcohol is in a 30% solution? Well, 30% of how much she has. How much does she have? Well, the 30% one, she has X of it. So the alcohol in it is 0.3 times how much she has. 30% of the liquid she has is alcohol. The other one, the Y one, 80% of that liquid is, so 0.80 of the Y is alcohol. And when she gets done, she wants something that is 50% alcohol. And how much of it does she have? She's got 70 liters. So this side is just 35, half of 70. So now we've got two equations that we can hopefully solve. We've got X plus Y equals 70, the first one that was easy. And the second equation, 0.3x, I'm going to get rid of the 0 there, we don't need it, plus 0.8x equals 35. So there's our two equations, and we have to solve those. I don't know, I think I'd probably use substitution maybe. I could also multiply this equation up here maybe by negative 0.3, that wouldn't be bad. Or by negative 0.8 and add the equations together. But I'm going to do by substitution, so I'll just resolve this one up here. I'll just take it and solve it for X. So X is 70 minus Y, and now I'll use substitution. So I've got 0.3 times X, but X I'm going to substitute out to 70 minus Y, plus my 0.8x equals 35. Now I've got an equation with only, hold it here, this one's the Y. There we go. Now I've got an equation with only y's in it, and I can solve that guy. So let's see here. 70 times 3 is 210, but you'd have to move your decimal 1. Times 0.3y plus 0.8y equals 35. So that's 0.5y. Note this is negative 0.3 plus 0.8, that's 0.5, equals, let's subtract this 21, giving us 14, and we'll divide by 0.5. Y equals, there's 28.5. So she's going to need, these things are all in liters, she's going to need 28 liters of Y, which is her 80% solution. Now we can come up here really quickly and we can figure out what X is, because X plus 28 has to equal 70, so that's what, 42. So you're going to need 42 liters of this one and 28 liters of the other. They add up to 70 like they should, and they'll give you the right percent alcohol. And we're done. Let's see here, number 22. 22, man, you see how they're solving for the exponent right there? Okay, so this is one that we actually want to convert back into or turn into logarithmic form. So there's a couple ways to do it. I'm going to do it the straightforward way, which says, hey, your base is 8. So this is a logarithm. Base 8 of 20 gives you the exponent, which is x plus 2. And finally, all we have to do is subtract that 2, and we'll know what x is. So we get log of 8, log base 8 of 20. And if you subtract 2, that tells you what x is. Okay, so they say find it algebraically. This is what they would like for an answer. The log base 8 of 20 minus 2. Now, to do this on our calculator does not do base 8s. Okay, our calculator only does base 10, so this is that change of base formula. Log base 10 of 20, the big number, over log base 10 of 8, the little number, minus 2. Okay, so that is just a direct thing to make it into a base 10 because our calculators do base 10. Well, I did have my calculator on here, and it must have gone to sleep on me, so let's see if we can put the read-only memory back into it. Why it keeps losing this. There we go. So on my calculator, I'm going to do the log 20. Base 10 it is. I don't have to write that in there. It just knows it. And I'll divide by log 8. Close that parenthesis. So there's the log 20 divided by log 8. Doing it base 10, then subtract 2. And it looks to me like x comes out to be negative 0.55. Let's just round it off there. Now let's go ahead and check that thing. So I think I know my answer is negative 5.59. So up here, if I want to check it, 8 raised to the negative 0.559 plus 2 should give us 20. So I'm just going to type that into my calculator the way it is. I'm going to go 8 raised to the, and I'm going to put it in parentheses, negative 0.559 plus 2. Now remember, this won't give us exactly the 20, probably, because we've rounded off the 0.559. There's all those other decimal places, so this will be close to it. And so we check it out. Yeah, it gives us about 20.01. So we're pretty confident. Yeah, negative 0.559 is my answer. All right, now we're back to something that we can deal with, hopefully. Okay, we've got a bunch of fractions here. Let's factor their denominators so we can figure out what the common denominator would be. Here we got a difference of squares. All right, so I've got to get rid of an x plus 3, so I'm going to put one of those in everybody's numerator. You got to get rid of an x plus 3, so I'll put one of those in everybody's numerator. I think they'll get rid of everything. So, in my first fraction, the x minus 3's would cancel, leaving me 2x times x plus 3. In my second term, the x minus 3's and everything cancels, giving me 6 minus 2x. And in the right-hand side there, I get x times x minus 3. Fractions are gone. Now it's just clean up the mess we created. So that's 2x squared plus 6x plus 6 minus 2x equals x squared minus 3x. Let's look for some like terms here. Well, I want my x squareds on the same side, so I'll subtract it from the right and the left. See, I got 6x, take away 2x, that's 4x's, but I'm going to add 3x more to it. That's 9 minus 2, so that's a total of 7x's. And then it looks like I just got that plus 6. I'm thinking this guy factors. x is -1 or -6. Let's see here. It doesn't blow up any of my denominators, so -1 and -6 are just fine. 24, we got x to the 4th minus 3x squared, because I'm going to take it to the other side. See, x to the 4th, we've talked about these guys. Lots of times they're in quadratic form, so you can break it apart as x squared, 1 times 4, negative, positive. Those add up to the 3 in the middle. Let's see here. These are quadratics, so you can actually solve them by setting them equal to 0 now. You could factor the x squared minus 4 further. You don't need to, though. We'll solve with the square root method. Get plus or minus 2. You're square rooting a -1 here, so we get plus or minus I, square root of -1. 4 answers to it. Plus and minus 2, comma, plus and minus I. And that is 4. Last two on this page, the equation that models the altitude of an airplane at takeoff is given by this. That's nice. It's nice and linear. See how it's t to the 1st power? That's just a line. This airplane just takes off and goes, where t is the time in seconds, h is the height of the plane, so this would be like time. This would be the height. As time goes, it gets higher. What is the slope of this function, and what does it mean? Well, our slope is right there. Remember, y equals mx plus b, so there's our variable t. 36 is the slope, so the slope is 36. And it's telling us height in seconds, so it's feet per second. That's its rate of ascent. So how fast it climbs. Slope is how fast it climbs. 36 feet per second. Slopes are rates. Very last one on this page, just solve this inequality, graph it and solve it. This one's got 2 variables in it. But it's a line, it's x to the 1st power. Subtract my 4x and divide by a negative. See what they're doing there? Seeing if you remember to flip it. So y is less than 2/3 x minus 3. Graph this guy. 1, 2, 3 is the y-intercept. Slope is 2/3 up 2 over 3. So it's going to be right there. And there's our line. Now be careful here. This is the line where y equals this. And so we are going to, take that line, we're made dashed. Because those points on that line don't make that inequality true. That would just show the ordered pairs that make it so they're equal. We want the ones where the y stuff is greater. And to do that, you have to do a little shading. You just say, hey, it's all the points above it. That's where the y is greater than this line. I should circle that line. Sorry, I was looking at the wrong equation. It says, when is it less than? So I'm going to erase a few things, bounce back here a little bit. I want this one less than it, so I'm not going to shade above it. I'm going to shade, things are going crazy, shade below it like that. There's where the y's are less than the 2x minus 3, or the 2/3 x minus 3. Okay, there we go. Just shade either greater than above it or less than below it, your line. And that should do it for that page.